Heike Kamerlingh Onnes. Heike Kamerlingh Onnes, 21 September 1853, 21 February 1926, was a Dutch physicist and a Nobel laureate. He exploited the Hampson-Lindau cycle to investigate how materials behave when cooled to nearly absolute zero and later to liquefy helium for the first time. His production of extreme cryogenic temperature led to his discovery of superconductivity effect in 1911. For certain materials, electrical resistance abruptly vanishes at very low temperatures. Biography, early years. Kamerlingh Onnes was born in Groningen, Netherlands. His father, Harm Kamerlingh Onnes, was a brickworks owner. His mother was Anna Gerdina Coers of Arnhem. In 1870, Kamerlingh Onnes attended the University of Groningen. He studied under Robert Bunsen and Gustav Kirchhoff at the University of Heidelberg from 1871 to 1873. Again at Groningen, he obtained his master's in 1878 and a doctorate in 1879. His thesis was New Proofs of the Rotation of the Earth. From 1878 to 1882, he was assistant to Jonas Boschet, the director of Delft Polytechnic, for whom he substituted as a lecturer in 1881 and 1882. Family. He was married to Maria Adriana Wilhelmina Elisabeth Bijveld, 1887, and had one child named Albert. His brother Mentha Kamerlingh Onnes, 1860-1925, was a fairly well-known painter and father of another painter, Harm Kamerlingh Onnes, while his sister Jenny married another famous painter, Floris Verster, 1861-1927. University of Leiden. From 1882 to 1923, Kamerlingh Onnes served as a professor of experimental physics at the University of Leiden in the Netherlands. In 1904, he founded a very large cryogenic laboratory and invited other researchers to the location, which made him highly regarded in the scientific community. The laboratory is known now as Kamerlingh Onnes Laboratory. Only 1 year after his appointment as professor, he became member of the Royal Netherlands Academy of Arts and Sciences. Liquefaction of helium. On 10 July 1908, he was the first to liquefy helium using several pre-cooling stages and the Hampson-Lindau cycle, based on the Joule-Thomson effect. This was he lowered the temperature to the boiling point of helium, minus 269 Celsius degrees, that is 4.2 Kelvin degrees. By reducing the pressure of liquid helium, he achieved a temperature near 1.5 Kelvin degrees. These were the coolest temperatures achieved on Earth at the time. The equipment employed is Boerhaave Museum in Leiden, the Netherlands. Superconductivity. In 1911, Kamerlingh Onnes measured the electrical conductivity of pure metals, mercury and later tin and lead, at very low temperatures. Some scientists, such as William Thomson, Lord Kelvin, believed that electrons flowing through a conductor would come to a complete halt, or, in other words, metal resistivity would become infinitely large at absolute zero. Others, including Kamerlingh Onnes, felt that a conductor's electrical resistance would steadily decrease and drop to nil. Augustus Matthiessen pointed out when the temperature decreases, the metal conductivity usually improves, or in other words, electrical resistance usually decreases with the decrease of temperature. On 8 April 1911, Kamerlingh Onnes found that at 4.2 Kelvin degrees, the resistance in a solid mercury wire immersed in liquid helium suddenly vanished. He immediately realized the significance of the discovery, as became clear when his notebook was deciphered a century later. He reported that mercury has passed into a new state, which on account of its extraordinary electrical properties may be called superconductive state. He published more articles about the phenomenon, initially referring to it as a supraconductivity and only later adopting the term superconductivity. Kamerlingh Onnes received widespread recognition for his work, including the 1913 Nobel Prize in Physics for the words of the comet, his investigations on the properties of matter at low temperature, which led inter alia to the production of liquid helium. The scientific discoveries by Heike, Kamerlingh, Onnes are well described in the book titled Nonlinearities in Microwave Superconductivity by Dmitry Ledenyov and Viktor Ledenyov. Legacy. Some of the instruments he devised for his experiments can be seen at the Boerhaave Museum in Leiden, Netherlands. The apparatus he used to first liquefy helium is on display in the lobby of the physics department at Leiden University, where the low temperature lab is also named in his honor. His student and successor as a director of the lab, William Hendrik Keesum, was the first person who was able to solidify helium in 1926. The former Kamerlingh Onnes Laboratory building is currently the law faculty at Leiden University and is known as Kamerlingh Onnes Building, often shortened to KOG. The current scientific faculty has a Kamerlingh Onnes Laboratorium named after him, as well as a plaque and several machines used by Kamerlingh Onnes in the main hall of the physics department. The Onnes effect, referring to the creeping of superfluid helium, is named in his honor. The crater Kamerlingh Onnes on the Moon is named after him. Onnes is also credited with coining the word enthalpy. Onnes' discovery of superconductivity was named an IEEE milestone in 2011. For information about honors and awards, selected publications, and additional references, see the web page. Thank you.